Hello, the code we wrote is based on the reaction of ammonia synthesis, or the Haber process. The chemical reaction for ammonia synthesis is 3H2 plus N2 yields 2NH3, and these are all gases. The reaction is reversible and exothermic. Ammonia synthesis is a key reaction for plant growth and a crucial ingredient in multiple fertilizers. Fun fact, it's estimated that 3 to 5% of the world's natural gas production goes toward the Haber process. Another fun fact, the Haber process produces about 500 million tons of fertilizer every year. Our code shows how the reaction of ammonia synthesis works. The user gets to input how much of each reactant gas they are using for the reaction, and they also get to choose what units they are using. As the code runs, it will show them the concentration of ammonia that they will produce over time. This allows them to choose the reactant amounts wisely in order to optimize ammonia gas production.
So as we go through the code, we imported our packages so that the calculations will function correctly. And then we have our constants set, such as temperature and the R constant in various units depending on the calculations that we're doing. The next part is we have the inputs for the N2 gas, and then these are so that they put in correct units, so if they put in some gibberish it doesn't work and they have to restart the code. Here is the unit conversions, so it converts it all into ATM so that the calculations work properly. And then these are our lower and upper limits so that it functions within the reasonable pressure limits of ammonia synthesis in reality. So if they put in some crazy high or crazy low temperature, it just won't work because ammonia synthesis doesn't work super well at those pressures. This is the exact same thing as we had for N2, but it does it for H2 when they input the pressure of H2. And then we convert those pressures that were inputted and we put them into concentration so that we can map out how the concentration changes as the reaction progresses. This is where we define the K of the forward reaction, the K of equilibrium, and then in turn the K of the reverse reaction. And we found these from the Gillespie and Beatty equation that we found online. And here we defined an equation that helps us map, again, as the concentration changes through time as the reaction progresses. And then we use ODINT for the calculations as we figure out how the concentration changes over time, and then we plot it with all of these various functions.
And then when we actually run the code, so we'll go through and run it. It'll wait just a second because it's loading. And then if we put in proper, reasonable pressures like 125 ATM, we don't want to put the ATM in that box. We need to put it in the unit box. And say about 3,500 PSI. Then it's going to run properly and give us the K constants and the different concentrations for N2, H2, and NH3. And then we get a beautiful graph. But if we had done something like we'd inputted wrong, written just gibberish, or I guess it's just letters, but, and then we said we want ATM units, it's going to ask for a valid number for N2 pressure. So then if we try to put in 6,000 PSI, it's not going to work because we need a lower value for N2 pressure. But then we can just go back and put in valid units like 200 ATM, and we can do the same for H2. And then we get a beautiful graph again. And so we hope you make good use of this code for ammonia synthesis. Thank you.